All right, so dilations day 2, and today we're going to do dilations on the coordinate plane when the center of dilation is the origin. That means for all of these problems, our center of dilation is going to be at the point 0, 0. So we're going to be given a scale factor, n, and we're going to be able to find the dilation by only looking at the ordered pairs. Now, this only works when your center of dilation is the origin. And we kind of saw this yesterday, where we noticed that when we had a scale factor of 2, our ordered pairs doubled in size. And again, that was because our center was at the origin. So we can do this where we take the original ordered pair, and we find the ordered pair of the image by just multiplying both x and y by our scale factor. So we're going to use this rule for number 1. Here in number 1, we're given this line segment BC, and we want to dilate it with a scale factor of 3. First thing I want to do is find the ordered pairs of the pre-image. So here we have our pre-image point B, which is at 1, 2. And then we have the pre-image point C, which I go over 5 up 3. So that's at 5, 3. Now our scale factor is 3. So for B, I'm going to take my original 1, 2, and now I'm going to multiply each by the scale factor. The scale factor was 3, so I'm going to multiply by 3 to each, and I will get the new ordered pair. 3 times 1 is 3, and 3 times 2 is 6. And now we found B prime. So B prime is at 3, 6. I'm going to go ahead and plot that point, 1, 2, 3, up 1, 2, 3, 4, 5, 6. And so we've got B prime here. Now we'll do the same for C prime. So we're going to take the original C, which was 5, 3. And I'm going to multiply by the scale factor of 3. And when I do that, I find, I'm out of the camera view. So I multiplied both by 3. 5 times 3 is 15, and 3 times 3 is 9. So C prime is at 15, 9. And I'm going to go ahead and plot that then. So I'm going to go over 15 and up 9. 4, 5, 6, 7, 8, 9. Should be right here. And that is C prime. So now that I've found those dilated ordered pairs, I can connect them, B prime and C prime, and we will get the dilated image. Right? Here's our pre-image. B prime, C prime is our image. Now let's just confirm that our center of dilation is at 0, 0. How do we know it's at 0, 0? Well, let's just show that it truly is by connecting the corresponding parts of our pre-image and image. So I'm going to connect B and B prime, and then I'm going to connect C prime and C. And look at that. Those two lines I just drew intersect right here at the origin. There's our center of dilation. Let's look at number 2. So for number 2, I'm given a triangle, and I'm already given the ordered pairs. Let's go ahead and actually plot this. So M is at negative 2, 0. So over negative 2, up or down 0. There's M. C is at 6, 7. So I go over 6, up 7. 4, 5, 6, 7. There's C. And then D is at 0, 10. So 0, 10 would be right there. That is D. And when I connect these, here is our pre-image. And now we're going to find the image. So I'm going to fill in our pre-image points right here. Negative 2, 0, 6, 7, and 0, 10. Now, in this example, our scale factor is 1/2. Since the scale factor is a fraction, what does that mean this dilation is going to do? That tells us this dilation is going to get smaller. So, how much is it going to get smaller by? It's going to shrink by 1/2. Now, we can still use the same rule that we did before, where we just take the ordered pair and multiply it by our scale factor, since our center of dilation is at the origin. So I'm going to start with the m, which we have -2, 0, and I'm going to multiply by the scale factor of 1/2. Now, 1/2 times -2 is -1. And 1/2 times 0 is 0. So m prime is at -1, 0. Now let's do the c ordered pair. So we're at 6, 7 right now. And then we're going to multiply by 1/2 to each. So 1/2 times 6 is 3. And 1/2 times 7 would be 3.5. So C prime is at 3, 3.5. Now you could have left that as a fraction, but decimals are a lot easier to plot. So I'm going to switch it to a decimal. All right, and the last one for point D, we're starting with 0, 10. And I'm going to multiply by the scale factor of 1/2. 0 times 1/2 is 0, and 1/2 times 10 is 5. So D prime is at 0, 5. Let's go ahead and plot those points. So M prime now is at -1, 0. There's my M prime. C prime is at 3, 3.5. So I'm going to go over 3 and up 3.5. So it's in the middle here. There's C prime. And then D prime is at 0, 5. So I'm going to go 0, up 5. There's D prime. And now I can connect these points. And notice that just as we had expected, our pre-image got smaller to give us our image. The image is smaller than the pre-image because our dilation had a scale factor of 1/2. So this is half the size of the original. Now, if you were to connect these points again, we would see that our center of dilation was at the origin, which is what we were given for all of these problems. Let's check out the last one, number 3. So in number 3, it says determine the scale factor of the dilation shown in the graph. So to determine the scale factor, we're going to use the ordered pairs of the pre-image and the image. So here we go. Let's start with the pre-image. For this example, which one's the pre-image, the larger or the smaller? It's the larger because notice C, B, D, E, no primes. C prime, B prime, D prime, E prime is the smaller one inside. That is our image. So we're going to start here on the outside. We'll start with B. B is at -6, 0. So remember, these are X, Y ordered pairs. That's how far we go over and then how far we go up or down. C, to find C, I go left 1, 2, 3. So that's -3. And then I go up 6. So C is at -3, 6. D, to find D, I would go left 1 and then down 1, 2, is that 3? Yep, down 3. So that's at -1, -3, XY ordered pairs. And now for E I go over 6 on the x-axis, and then I go up 2 on the y-axis. So that's 6, 2. Now let's go ahead and find the image points. So for the image, we're looking at B prime now. So for B prime, I go over 1, 2, 3, 4 to the left, and I don't go up or down at all. So that's -4, 0. For C prime, we go left 2 and then up 4. So that's -2, 4. For D prime, we go left 1 and then down 2. So that's negative, ooh, that's not a full 1, is it though? That looks like it's about here. So let's say that's about 3/4. So negative 3/4, comma, negative 2. And then the last one, E prime, I go over 4 and up. Now this one doesn't seem to be quite at 1. It looks to be about, hard to tell. Now, if it's a little bit hard to tell, I know that my x value is 4. I really only need one of these points in order to find the scale factor, because the scale factor works the same in all of them. So even for this one before that was a fraction, it's okay to leave that if you have some other ones that aren't. I'm going to use these two, and then I'm going to use the scale factor to confirm what we are thinking for E prime. All right, so how do I find the scale factor? Remember, to find the scale factor, we're thinking new over old, or image over pre-image. I'm just going to do N over O or I over P. So we're going to take our image point and put it over the pre-image point. So let's just start with the very first one, B and B prime. And I'm going to take the image x, so negative 4, and divide it by the image's y, which are that pre-image is x, which is negative 6. Now, looking at this, I chose the x's and not the y's because the y's are 0. So because they're both 0, that's not going to tell us what the scale factor is. We want to choose the ones that have numbers. Okay, so here, when I see negative 4 over negative 6, I'm going to reduce this fraction. A negative divided by a negative is a positive. And then 4 over 6 would reduce to 2 over 3. So there's our scale factor, 2/3. Now I can use the scale factor in order to determine these other points. Now, it might be helpful if you're not totally sure if your scale factor is correct to check your scale factor in the second pre-image and image point. If I chose the correct scale factor, I should be able to get from this x value to this x value, or this y value to this y value. Let's test it with the y's since we already looked at some x values. So to go from 6 to 4, I should be able to take the pre-image point 6 and multiply it by the scale factor, 2/3, and it should equal 4. This is what we're testing. I'm going to use my handy-dandy calculator because sometimes fractions can be hard. So I'm going to multiply 6 times, and if you're using a calculator like this, make sure that you put the fraction in parentheses because mine doesn't pop up with a nice little fraction thing. So 6 times 2/3, and fingers crossed that it equals 4. It does, right? So we have confirmed that we chose the correct scale factor. Now I could use that scale factor to find E prime's y. So what am I going to do? I'm going to take the y value from the pre-image, 2, and I'm going to multiply it by my scale factor, which is 2/3. Now in my calculator, it's giving me a decimal. If I hit math and then choose the fraction, enter one more time, it tells me that it is at 4/3. Now, I could use this to confirm D prime here. We estimated it to be negative 3/4, but now we actually know the scale factor. So let's double check because we might have been off a little bit. If I take the pre-image x, negative 1, and I multiply it by the scale factor, 2/3, I got a decimal, math, enter. Oh, it should actually be a negative 2/3. So the real point here is negative 2/3, comma, negative 2. So if you ever see those fractions, I would suggest that you use the ones with whole numbers first, find your scale factor, and then use your scale factor to find the accurate points for the image.